Hello all, from this video onwards we will dive into the actual content of digital image processing. In this video, first we will try to learn the basic definitions. Say if you know digital image processing or you say image processing is one of your key skills, then it is mandatory that you know very few definitions like what is an image, what are the building blocks of an image, and what is the difference between computer vision and image processing. Why do we explicitly mention the word digital? Is there something like analog image processing? That is what we'll be trying to see in this video. Before we get into the definition of an image, there are few terms like digital image processing, digital image analysis, also known as digital image understanding, machine vision or computer vision, computer graphics. Are they all same? Because they are all related to image itself. Are they all same? Are they just synonyms for each? Actually, they are not same. They are quite different, but there is no clear-cut order line that these tasks come under digital image processing. These tasks come under computer vision. But what we like to define as per Gonzalez textbook is, in digital image processing, you give image to a digital system. It could be a software that is developed using MATLAB, Python or C or C++, and what you get is a processed image. In digital image analysis or understanding, you give image to a computer and what we get is a features or information. For example, you give the image of a road scene. So what all are the features or information that you get? You see that there is a road, you see that there is a road sign, so you try to get those information. And in computer vision, you identify whatever objects that you have understood from the previous image analysis. You try to categorize them, that this is nothing but a road sign which is trying to say a speed limit. This road sign is trying to say it is no parking. This is a road, this is a footpath, like that. And how is computer graphics different? Computer graphics, you can call it as, you see from the block diagram, you can call it as the inverse of computer vision. But what is computer vision? Is computer vision same as AI? Right? See, AI has many algorithms if for different types of data. So if the data format is text, then there are certain algorithms which comes to natural language processing and all those. If the data format is images, then we have convolution neural networks and all those. So what is this overlapping between computer vision and AI? So those algorithms which are designed for images, that is what computer vision and AI, that is where computer vision and AI overlap. So apart from the algorithms of AI, there are many pre-processing steps. Actually, with respect to computer vision, digital image processing can be considered as a image pre-processing step, and you have to do digital image analysis and then only you can recognize the object. So computer graphics, as you can see from the block diagram, you give some interpretation of the scene and that is going to generate an image. You can call computer vision as the reverse process of computer graphics and vice versa. So again, there is no clear-cut boundary between image processing and computer vision. What exactly is computer vision? What are the tasks? But in a computerized process, when you are trying to develop a software, this image processing comes under computer vision, which we call it as image pre-processing in the realm of computer vision. There are three paradigms in the computerized process, how you achieve the final computer vision output. So first is called as the low level process, where you try to do some basic operations such as sharpening the image, remove noise, so that the output of the computer vision algorithm is more suitable. What do you mean by more suitable? That the computer is able to visualize and understand from the image more similar to that a human brain and eyes can understand. And the mid-level process, you do some operations like segmentation. Suppose you have taken the x-ray of a chest. What is segmentation? You are trying to get only the lungs part. You are not trying to get the shoulders or head that also comes along with the x-ray. And you are trying to classify the objects there, which pixels belong to which object. Now you have classified certain part of the image belonging to object number 1, object number 2. In high level processing, which is the final stage of computer vision, which is imbibing the or imitating the human vision system, You are trying to recognize those objects. This object is a car, this object is a bike, this object is water, like that, and you are trying to make some decisions. For example, you can take a satellite image of the glacial melt and compare how much of melting has happened by analyzing how much of area is reduced of the glacial sheet, the ice sheet. Those are the final operations which is considered to be the high level processing in the computer vision. But before you achieve that, you need to do some pre-processing and some image analysis and all those, and then only you can recognize and take some actions. We will see whatever we saw in the previous slide with an image. See, suppose this is the tiger. First you classify it as a tiger. You need to do some pre-processing. Whatever image that you have, it must be suitable. Maybe you increase the contrast, something like that. That comes under image pre-processing or low level processing. Then you are trying to classify the objects. See, this green part belongs to one object and this blue part belongs to one object. In the final processing, you are trying to recognize this object. This object is called as water, this object is grass, like that. That is the high level recognition for the final computer vision. And now, why do you require digital image processing? So there are three main reasons why you want to process an image that you have taken. One, you want to improve the human perception. Suppose, why do you all apply filters on Instagram? You, whatever image that you have taken from your phone camera, maybe it is not good, or you want to look much better. So to improve pictorial information for human perception, we do digital image processing. The next one is for the machine application. Machine application, that's where we get the name machine vision or computer vision. Suppose you have manufactured hundreds of PCBs. How do you know the PCB manufacturing is perfect? Can you verify it just by looking into it directly with your eyes? No, because it is very small, correct? So what do? You take X-ray of the PCB and compare it, and then you can find the defaults, whether the manufacturing was proper or is there any defect in the manufacturing. And today in the digital era, so much of data is generated. The data could be not only in the form of text, it could be in the form of images, video. So you need to store those data somewhere. You have Google Photos for backup and transmission. Say Google Photos, what is the maximum limit that you have, or Microsoft, if you take premium also, everything is limited, correct? It is 1 terabyte, 100 GB. So you cannot have infinite amount of storage. That's why we need some limited storage, and also transmission is efficient. Suppose I send you a photo today, it should not reach you tomorrow. So efficient here means fast with respect to transmission. Storage means efficient storage here. Efficient means minimum amount of storage without compromising on the quality of the image. So for either of these three reasons or all of these three reasons, we process the image that we have obtained. Now let us get into the actual definition of an image. So image processing comes under a field called as signal processing, which is usually a core subject for both computer science and electronic students. So what is a signal first? So a signal is a mathematical function which is depending on some variable that has some physical meaning. The word physical meaning plays a very important role. Just because you have some numbers, does that doesn't form a signal under the signal processing context. It might be called as a data but not a signal under signal processing context. So depending upon how many variables you have, independent variables, we have one-dimensional signal, two-dimensional signal, three-dimensional signal. So in a one-dimensional signal, there is only one independent variable. The best example is a voice signal, where the independent variable is the time axis and it is denoted as f of t because it is a function of time. This is a representation. So at 0.5 my voice is high, at somewhere here my voice is further high, and around 1.5 my voice is low. So there are some variations or amplitude variations with respect to time. So voice is, and there is some meaning to my voice. I am conveying you some message in my voice. You are able to analyze it. In this context we are trying to analyze what is a signal. Where have you seen this representation? One best example where you have seen is in the WhatsApp voice messages. Now you can see at this voice message is of 5 seconds length or 18 seconds length. At each point the amplitude is varying or decreasing. So this is an example of a signal where there is some physical meaning. You are trying to understand something from it. Right. Now what is an image? Similarly, an image is also a signal. So it is defined as a signal and mathematically a two-dimension function represented as f of x comma y. For voice, the independent variable was one, which was time axis. Here there are two independent variables, that's why we call it as a two-dimension function mathematically. X and y are called as the plane coordinates or spatial coordinates, and the value of f at x comma y, which is called as the amplitude, is called as the intensity level of the image. So what is this intensity level? What is it trying to convey? That is where we have the physical meaning. So this intensity level is usually a brightness, the color sensation, which depends from one person to another person's eyes, but it could also be a temperature and pressure. So usually the photo that we click from our camera, it could be phone cameras or anything, that is nothing but the f is nothing but the brightness descriptor there. You can also have different sources of image. It need not be only from a camera, it could be from a thermal camera or from sonogram. Here all, what is the sound wave in sonogram? The sound wave is converted to an image. Here what is the amplitude f? Amplitude f here is the temperature. So the red indicates hot, like blue indicates it is the cool region. So the amplitude f need not be always brightness, it could also be temperature, pressure, depending upon the source of your image, from where you are taking, through what means you are taking that image. So why do we call it a digital image? Does that mean there is something called as analog? First we will try to understand what is digital. In digital, we mean that the location x comma y and the value of f at particular coordinates x comma y all are finite and discrete. They are not infinite. So digital image processing means you are trying to manipulate a digital image where the values of the image, the locations in the image, everything is finite and discrete using some digital system like a computer. So a digital image is represented or stored as a matrix of finite discrete numbers, but finite discrete numbers, they should have a meaning, because digital image is a signal and a signal should always have some physical meaning associated with it. And coming to the major term in the digital image or any image, there are two terms. One is the value f. The value f or the number at a particular location x comma y, you call it as the intensity value, gray value or the pixel value. And the location at particular x comma y we are telling, correct, that is called as pixel, which is combination of two words. Just like Virat plus Anushka is Virushka, picture plus element is pixel, or you call it as pel or image element. So the basic building block of an image, you call it as a pixel. Thank you.